Yesterday, we talked about reference angles. Are we good? Okay, so yesterday we talked about reference angles. We also talked about finding our different trig functions when you're given like a random point. And so we have this like random triangle here. This is basically like an extension of this, except now our hypotenuse is always going to be 1 because we're going to be on the unit circle. So I want to remind you guys of something from geometry that you all loved so much. Do you guys remember the 30, 60, 90 triangle? Yeah. Okay. Well, that's basically what the unit circle is it's taking advantage of these triangles. So the unit circle, which we're going to get to in a second, this is our unit circle, right? Let's not forget that it's on a coordinate plane where this center part is your origin 0, 0. Okay. And then it's 1, our radius is 1. So our coordinates would be like 1, 0 here. And I'll get back to that in a second. So let's see how this 30, 60, 90 triangle works. So if you guys draw like this bottom line here and make this a triangle, this angle here is at 30 degrees. Okay, this is 30 degrees. So this is a 30, 60, 90 triangle where my 60 degrees is up here. What that means, if you remember your rules from the 30, 60, 90 triangle, this length here is not technically it is, it's the square root of 3 over 2. That's using that 30, 60, 90 rule. And this height would be 1 over 2. What that means is if this length is the square root of 3 over 2, as a coordinate point, that's our x, right? And our y would be 1/2. Zakira, can you shut my door for me? Sorry. Thank you. So that's this point just using our 30, 60, 90. I'm going to jump down to the bottom one now because I still want to be thinking about the 30, 60, 90. But now I'm just going to like rotate my triangle or reflect it or whatever happened here. It's a rotation, I guess. Maybe and a reflection. So this is actually still your 30, 60 triangle. But now this angle down here by the origin is 60 degrees. This length here is still 1. And I'm sorry, I should have put this length as 1. Okay, that's how I got from the rule if your radius is 1. So then if the radius is 1, that makes this length here 1/2. And this length would be the square root of 3 over 2. Do you all kind of remember those rules from the 30, 60, 90? Sort of. No? Go back. Can you go back to the top one? Yes. So the top one, our radius here, our hypotenuse of our triangle is 1. So the rule would then make this square root of 3 over 2 and this one 1/2. And since this is a length on our x-axis, that is our x coordinate, right? And this is a length on our y-axis, so this is our y coordinate. So likewise, down here, this length is our value of our x coordinate, so that'd be 1/2. And this length here would be the value of our y coordinate, which is the square root of 3 over 2. So the points that I'm going to show you on the unit circle aren't arbitrary. They come from these 30, 60, 90 triangles. Anyone have a guess what triangle this would be? Yeah, the 45, 45, 90. So the one in the middle. Triangle in the middle is our 45, 45, 90. So that means this is 45 degrees. If this is 1, that means that this length right here is the square root of 2 over 2. And this length is the square root of 2 over 2. And again, that gives us, if you consider this point up here, that gives us that our x is square root of 2 over 2, and our y is the square root of 2 over 2. So this is just like what our unit circle is made out of, and it's taking advantage of these nice right triangles, because obviously you could draw other angles in here, but they're not going to follow these rules. Our unit circle is going to follow just the ones where it's a 30, 60, or a 45, or like a 90, where we have certain angles that we care about, I guess, or that we can easily name them. Okay, so are we good to jump to the main circle? Let's do this main circle. So again, I won't have you memorize this whole thing, but honestly, we're gonna work our way around this circle, and I think you're gonna see that, like, if I asked you to memorize this whole thing, it's not that bad. But let's go ahead and start with the things we know. So some things we know. I already told you this is our origin here. So that means this is 1, 0, right? Our x is 1, our height is 0. That means that this is 0, 1. This would be -1, 0. And then on our bottom, we'd have 0, -1. We all good with that? Okay, because again, we're on a coordinate plane. All right, let's go ahead and do our degrees first. And I'm not going to do all my degrees. I'm going to do the ones that I know for sure first. So I know that this is 0 degrees. This top one is 90 degrees. This is 180 degrees. The bottom would be 270. And then I have a repeat here. This would be 360. I think that's all. That's like what we know from, I don't even know what grade you would do these. Maybe 8th grade? I don't remember. We know these though, right? We're good with these. Yeah. All right, so let's start by, I'm going to be skipping. So if you notice 30 to 45 to 60, that's not like an even increment, right? So let's just do the 30s first. So basically, and you can do this in your calculator if you want, but what we're going to do is we're going to do 0 plus 30, obviously is 30. So this is my 30 degrees. And then I'll do another plus 30, and I get skip a line. I get that this is 60 degrees. And then you can start just hitting enter. We get our 90 degree. If I hit enter again, then my next one will be 120. Skip a line, I get 150. If I hit enter again, I get 180. Enter again, this is 210 degrees. Skip a line, because we're skipping our 45s. This is 240. Enter again, that's 270. Enter again, this would be 300. Skip a line, we have 330. And then we'd have 360. Okay, so we just went around and filled in all of our degrees for the 30 degrees. Now the trickier part is the radians. So if you're not sure like what proportion of the circle this is, what you can do is you can do 30 divided by 180. Remember there's like, it's like 2 pi instead of pi. So then if you turn this into a fraction, we know that this is 1/6. So each of these slices are 1/6. Follow me on that? Mm-hmm. So that means for my radians, and I'm going to switch up my colors here because I'm a little extra with the colors today. My radians, this is still 0 radians. But then my first 1/6 of the chunk would be pi/6. And again, it's pi because if you remember, this 180 is equivalent to pi. So a full pi, not a full pi, but a half circle is pi. So pi/6 gives me this first chunk. Then if I do, and I'm going to do something crazy here. I'm not going to reduce for a second. We'll come back and reduce. Skip a line, but this would be 2 pi/6. 3 pi/6. 4 pi/6. Skip a line. 5 pi/6. This one would be 6 pi/6. I've already reduced it. We're going to go back and reduce everything, but this would be 6 pi/6, which means this would be 7 pi/6. Skip a line. 8 pi/6. 9 pi/6. 10 pi/6. Skip a line. 11 pi/6. And then our last one would be 12 pi/6, which reduces to 2 pi. Okay, so we're not crazy people. We know how to reduce fractions, but I wanted to show you with just adding those for a second so that we can just see we really are just adding a 6 each time, right? Mm-hmm. So then what happens is we need to go around and reduce. So 2/6 is the same as 1/3. So this one just becomes pi/3. 3/6 becomes 1/2. So this would be pi/2. 4/6 will reduce to 2/3. So 2 pi/3. 5/6 does not reduce. I already reduced my pi. 7 pi/6 does not reduce. 8 pi/6 reduces to 4/3. Or pi/3. 9/6 will reduce to 3/2. So 3 pi/2. 10/6 reduces to 5/3. 5 pi/3. 11 over 6 is reduced, and then I already reduced 2 pi. So if I asked you to like memorize and just do this part, can we do this? This isn't even memorizing anything. I think this is just inching your way around. Okay, that takes care of my 30 degrees. Now let's look at our 45 degrees. I'm going to do this in a different color again. So now we're going to add 45 each time. So if you do this, it'd be 0 plus 45 is obviously 45. 45 plus 45 is 90. Add another 45, and we get over here, which is 135. Add another 45, we're at 180. Add another 45, we'd be at 225. Add another 45, we're at 270. Add another 45, we're at 315. And then our last 45 would take us back to 360. Again, I think we're all fairly familiar with that part anyways, with our degrees. But now let's think about in radians, what proportion is that? Well, again, if you're not super good with proportions, you can do 45 divided by 180, turn it into a fraction if you really need to, and it's 1 over 4. So that means that my radians are going to be increasing by pi over 4 each time. So 0 to pi over 4. Add another pi over 4, it'd be 2 pi over 4, which reduces to pi over 2. Then it'd be 3 pi over 4. 4 pi over 4 would reduce to pi. 5 pi over 4. 6 pi over 4 reduces to 3 over 2, or 3 pi over 2. And then 7 pi over 4. And then our last one would be 8 pi over 4, which again reduces to 2 pi. So I think on the first day when I gave you that teeny tiny little unit circle, we did this really fast, but now we have inched our way around it very purposefully. Do we have any questions about like filling this part in? Like if I asked you to do this, I feel like you could all do this. Yeah. Okay, the tricky part, the stuff with those triangles that I just talked about. You don't have to write this part if you don't want to, because I'm going to use my highlighter and just draw on our pretty picture. But let's not forget that right here, we have that 30, 60, 90 triangle, right? And we already filled this out on the other page. I said that this length here was the square root of 3 over 2. And this height here is 1/2. Then if we just take this triangle and we like flip it or whatever, I don't even know what transformation is happening here. If we flip it, right? It's still the same triangle, but now our height and our like width or our base have swapped. So now it'd be 1 over 2 as our x and the square root of 3 over 2 as our y. And then our 45, 40, which I won't draw this again just because the picture will get too confusing. But this, remember, is the square root of 2 over 2 and the square root of 2 over 2. Those aren't just arbitrary numbers. They are the lengths of our legs of these triangles, where our radius is always 1, so our hypotenuse is always 1. Okay, so this is like officially the part that you have to like memorize, I guess. But if I asked you to memorize this whole thing, it's actually really easy because notice we have some symmetry. So if you look here, isn't this the exact same triangle just flipped under? So that means my x value would be the same. It'd still be the square root of 3 over 2, but now my y is just negative 1/2. Likewise, this triangle, we have the same symmetry happening. Okay, our x value is the same, be 1/2, but now my y is negative square root of 3 over 2. And our 45 triangle does the same thing. Same x, square root of 2 over 2, negative square root of 2 over 2 for my y. Oops, sorry, I'm off the page. So if you really like didn't want to memorize this whole thing, what you can do is you can just take this picture of the triangle and translate it over and see, okay, what ended up where? And I'm going to just give you the rest for time's sake. But what ends up happening, and here's another thing you might want to write, you will find that your x and your y will both be positive in quadrant 1. In quadrant 2, once I give you these values, we're going to see that our x is negative and our y is positive. In quadrant 3, everybody's negative. Bunch of negative Nancy's down there. I don't know. Negative x, negative y. Negative, positive, right? Because it's negative x, positive y. And then in quadrant 4, our x is positive, but now our y is negative. So it's like a reflection of quadrant 2. So we can do that with like reference angles, and I'll show you like a couple different ways to find these angles, or these sides, but we'll do that in here in a second. Let me give you the rest of the unit circle. So again, I'm going to do this quickly just because for time's sake, but you could figure these out by just moving these triangles around. This one would be -1/2, comma, square root of 3/2. We love our 45 one because we know it's just going to be negative square root of 2/2, positive square root of 2/2. And then this one, we're going to flip these two, but it's going to stay negative on the x, so negative square root of 3/2, and then positive 1/2. For our third quadrant, everybody's negative. And again, if you think of this as like a reflection of this triangle down, the x is going to stay the same, negative square root of 3/2, and the y is just going to become negative. Same thing here, that stays the same, but both parts will be negative. And then same thing here, this triangle is the same, just flipped, so now it's going to be negative 1/2 and negative square root of 3/2. So like honestly, if I asked you to memorize this whole thing, you think you could do it? I think it would take a while to fill out, but like, yeah. I don't even know if memorizing it is the right word. It's more like how you fill it out and just kind of going through the steps. Any questions about the unit circle? Okay, so I gave you a ton of stuff here with the unit circle. I have a typo in this one. Let's change it really quick. I switched these for some reason. That should be cosecant, and that should be secant, so save yourself some heartache. So you can fill this out if you want. I like in mine, which I now made a mistake, I realized, but I have this whole thing like filled out. If you want to do that, just so you have them. It's fun just to do it, but you don't have to. But it has the same thing about like the 45 triangle, the 60-30. I won't fill those out again, but if you want to kind of have this as a reference. How we're actually going to use these. The fun stuff. Okay, so first of all, there's one weird thing that comes out of these in terms of like finding our angles. And these are something called quadrantal angles. So a quadrantal, sorry, I don't have a ton of room here, angle. Okay, quadrantal angle is an angle in standard position whose terminal side lies on an axis. The measure of a quadrantal angle is always a multiple of 90 degrees or 2/pi radians. The reason these are weird, I guess, is because sine and cosine and tangent and cosecant and secant, all those things, those are all ratios of sides of a triangle, right? But if you think about your unit circle, like where's my triangle for right here? Right? It's like right across this way. But then that's not really my triangle because I don't want my 90-degree angle here. So it's weird. It really is like a line. So I don't even know how to picture it or how to describe it. What we're going to use, though, is from a couple pages ago. I'm going to rewrite it here. I don't know why I put it in a different spot. We're going to use the fact that sine of theta equals y/r. Cosine of theta is equal to x/r. And tangent of theta is equal to y/x. And remember, for a unit circle, r equals 1. Because that's our radius. And then we don't have to think about the triangle too much for these quadrantal angles. So what I mean by that, example 3 wants us to use the unit circle to evaluate the 6 trigonometric functions of theta. So, and I'm just going to write it down theta, but this is technically sine of 270. I'm just going to write theta because it's quicker. Sine of theta, cosine of theta, tangent of theta, across from this cosecant of theta, because those are inverses, secant of theta, not inverses, sorry, reciprocals, and cotangent of theta. Okay, so I have my reciprocals across from each other. Because if they're reciprocals, remember sine, if the sine is y/r, cosecant's going to be r/y, right? Okay, so sine of 270. If you look at your unit circle, eventually, 270 is down here. This is a quadrantal angle. It's on this axis. So sine, by definition, is y over r. So it'd be -1 over 1, which is just -1. Cosine is equal to x over r. So it'd be 0 over 1, which is 0. What about tangent? What happens with my tangent? It's y over x, so I'd end up with -1 over 0. What's the issue? Undefined. I didn't leave myself enough room to write that, but you can abbreviate it as UND or whatever, but this is undefined. And you'll notice if you actually like type this into your calculator, if you do tangent of 0 and you hit enter, wait, why is it 0? Did I have this backwards? Yeah.
Can I have the door open the desk to the office, prepare to leave, please?
Yes. You heard her. Bye. I typed the wrong thing, so yes. That's too funny. All right, so sorry, I typed the wrong thing. Tangent of 270. That's really funny. You get a domain error because it's undefined. All right, so let me see here. Cosecant, you just switch things. It'd be 1 over -1, but that's still -1. Notice now when I do my cosine, when I switch it for secant, suddenly it's undefined. And cotangent will become 0 divided by -1, which is defined. 0. I will record these, so if you miss them, you'll get them. Questions about these ones? For time's sake, do you want me to do this one or should I skip it? I'll skip it. Or actually, this one isn't a quadrantal though. No, I should do it. I should do it because it's not quadrantal.
Oh, yeah.
Sorry. Okay, so part B, this is not a quadrantal one. This is 45 degrees. So when I find my sine, my cosine, and my tangent, it's actually a little more interesting. I have to do rationalizing the denominator and all that stuff. Okay, so 45 degrees. Again, on my unit circle, I find 45 degrees is here. So it's square root of 2 over 2 stuff. So sine would be the square root of 2 over 2 over 1. No, yes. Tripping myself out. So that just ends up being square root of 2 over 2.
Okay, wait, I'm confused on how you're doing the numbers. Like,
This is my y.
oh,
That's my r.
That is
R is 1. Y is right from here.
got it. Thank you.
Cosine ends up being x over r. So again, it's square root of 2 over 2 over 1, which is just square root of 2 over 2. Tangent is y over x. So this one's a little weird. I end up with square root of 2 over 2 over the square root of 2 over 2, which would be what? 1, because those cancel out. And then cosecant, you flip everything, but then you have to tragically rationalize the denominator. So you would end up with, you'd multiply by square root of 2 over 2. So I think you just end up with a square root of 2. If you rationalize, you just end up with square root of 2. And actually secant will do the same thing. And then cotangent will still be 1.
Wait, I know it's good.
So for secant, well, you get 2 over square root of 2, but then you multiply the square root of 2 over square root of 2. So you end up with 2 square root of 2 over 2. It reduces to square root of 2.
Yeah.
Okay, so one thing to note, and this I will show you, I guess, both ways. The book does it both ways, and it sort of depends. I didn't show second hour this. I need to go back and show them. It depends on what you're given. So if you know your whole unit circle, great. If you don't, if you only know the first quarter, this is another thing that you can kind of like know. Sine and cosecant will always be positive in quadrant 2. Cosine and secant will be negative in quadrant 2. Tangent and cotangent will be negative in quadrant 2, and so on. So you can like know these, I guess. And then actually evaluating these is there's 2 ways to do it. I'm going to show you like the easy way if you have the unit circle with you. So the easy way here, we have tangent of negative 240 degrees. Negative 240 degrees is not on my unit circle. I need to find the coterminal side. So the coterminal angle would be negative 240 plus 360, and I get that it's 120 degrees. Okay, so if it's 120 degrees, if I have my unit circle all the way memorized or I have access to it or whatever, finding tangent of 120 is just you take tangent of 120 degrees. You look here at 120 degrees. Tangent by definition is y over x. So it'd be equal to the square root of 3 over 2 over negative 1 over 2. You can go ahead and just take the reciprocal. So you do the square root of 3 over 2 times negative 2 over 1. That's how you divide by a fraction. You guys remember that? Keep, change, flip. Those cancel out and you end up with negative square root of 3. Okay, that's the first way to do it if you have the full unit circle, which is great. Say you didn't have the full unit circle. Say you only have quadrant 1 memorized. The coterminal angle is not in quadrant 1. So this is where, and your book does it this way, switch colors. They find then the reference angle from this 120. So of 120 degrees. So they do 180 minus 120, and they find that the reference angle is 60 degrees. Now they have to use this table. You have to know in this table, okay, I know that 120 is in quadrant 2, and I know that tangent in quadrant 2 is negative. So I'm going to instead say negative tangent of 60 degrees. Because I only know quadrant 1. In this specific example. Then you would just look in quadrant 1 and you do your y over your x. So it'd be square root of 3 over 2 times 2 over 1. But remember we said negative, so you just throw a negative out there and you still end up with negative square root of 3. I want to show you both ways because I don't know if I'm only having you memorize quadrant 1 of our unit circle. I think that means I can't give you the rest of the unit circle. So unless you know the rest of the unit circle, you need to be able to either know the rest of the unit circle, and you can do it the first way, or you need to know the sign of your different trig functions in the different quadrants, and then you can just use the reference angle. Olivia.
How did you find the reference angle?
That's those rules that we talked about yesterday. So that's like the where's those? These ones. So remember the reference angle is like if you're in quadrant 2, you do 180 minus theta. And it's describing this little angle right here. If you're in quadrant 3, you have this full angle, but you want to find this little angle here, you do theta minus 180. It takes you to like the closest axis and you always make it positive. And that's how we can use it for these ones. So maybe today on your homework, you want to do it both ways just for practice. I'm going to do part B really quick and then I'll turn you loose. Part B. And I don't think I did part B with the reference angle. I just did it like with the coterminal. So the coterminal for 17 pi over 6, because now we're in radians. This is outside of my 2 pi. So I need to subtract 2 pi from both, or from this 17 pi over 6. But 2 pi is the same as 12 pi over 6. I just needed to get a common denominator. Okay, so this is like me subtracting or adding 360 here. I added 360 because it was negative on this one. I'm subtracting 360, except I'm doing it as 2 pi because it's in radians. And so I end up with 5 pi over 6. So I'm going to find cosecant of 5 pi over 6. Now, as a reminder, sine of theta is equal to y over r. So that means cosecant, which is our inverse, not our inverse, I keep saying inverse, our reciprocal, is r over y. And r is 1 here because we're in the unit circle. So on my unit circle, I'm going to go ahead and find 5 pi over 6. It's in my second quadrant here. It's negative square root of 3 over 2 over 1/2. I just need the 1/2 part because I need the y. So it's 1 over 1/2, which ends up giving me 2. So it's a little strange using this unit circle, but I don't think it's super, I don't think doing it is difficult. I think the beginning interpretation of what to do is a little challenging. So your homework is posted. Stop recording for a second.